Welcome back everyone to 3 Inquisitive Kids. In this video, we will be talking about the triangle interior angle sum theorem. Our course outline for this chapter, chapter 7, consists of 7 separate videos. We are actually on our second to last video of this chapter. Our learning goals for today is to be able to use what we've already learned in the previous lessons to prove the triangle interior angle sum theorem, and be able to apply the triangle interior angle sum theorem onto problems. One day, 3 different types of triangles express their own understandings of the sum of their interior angles. Are they right or wrong? This first triangle says, I'm the largest, so my angle sum must also be the largest. This other triangle says, I have an obtuse angle, which means my angle sum must be the largest. And the smaller triangle says, I'm the smallest, so my angle sum must be the smallest. Are they right or wrong? We already know that the sum of the interior angles of any triangle is equal to 180 degrees, and it has nothing to do with the shape and size of the triangle. How else can you verify that the interior angles of a triangle has a sum of 180 degrees other than by just measuring? Here, this animation shows that we can fold the 3 corners of this triangle together to form a straight angle, and we already know that a straight angle is always 180 degrees. We can also measure. "60 plus 48 plus 72 equals 180 degrees. But earlier on in this chapter, we learned that by just measuring and giving examples is not a very reliable way to prove a proposition right. We are given triangle ABC. Prove angle A plus angle B plus angle C equals 180 degrees. Well, here you can see we drew line L, and it's parallel to line BC. And so angle A and angle B should be equal. And this angle and angle C should also be equal. And this is using the alternate interior angle theorem. We first draw line L, and that's parallel to BC through point A. Therefore, angle B equals angle 1 using the alternate interior angle theorem. And angle C equals angle 2. Because angle 2 plus angle 1 plus angle BAC equals 180 degrees, angle B plus angle C plus angle BAC also equals 180 degrees. And these angles are all of the interior angles of this triangle. Method 2. We can extend BC to point D and make CE parallel to BA through point C. Here you can see we've extended line BC and we made CE parallel to BA. Therefore, angle A equals angle 1, again using the alternate interior angles theorem. And angle B equals angle 2, the transversal angles axiom. Also, because angle 1 plus angle 2 plus angle ACB equals 180 degrees, therefore angle A plus angle B plus angle ACB equals 180 degrees. Method 3. We can make DE parallel to AC through point D and make DF parallel to AB. Therefore, angle C would be equal to angle EDB, and angle B would be equal to angle FDC, all using the transversal angles axiom. And angle A plus angle AED would equal 180 degrees. And angle AED plus angle EDF would equal 180 degrees, using the same side interior angles theorem. Therefore, angle A would equal angle EDF, and because angle EDB plus angle EDF plus angle FDC equals 180 degrees, therefore angle A plus angle B plus angle C also equals 180 degrees. If you want to pause the video and look over this solution one more time by yourself, feel free to pause the video. Here you can see we rearranged the angles of the triangle. Knowledge point. What are auxiliary lines? Well, these lines are extra lines drawn on the original given diagram, and they are called auxiliary lines. And usually when you're solving a geometry problem, they can act as guidelines or help you look at this problem from another point of view. And then usually they're drawn as dotted lines. In order to prove the sum of a triangle's interior angles equal to 180 degrees, we can combine the angles into one straight angle. You can see that a lot of the derivations we've looked at all include putting the three angles together to form a straight angle. And they're technically transforming or teleporting this angle from here to another place. And this method is commonly used when you're solving geometry problems. So you're taking this angle and putting this angle somewhere else that you know where it will be equal. Here is the application of the triangle interior angle sum theorem. Example 1. As shown in the figure, in triangle ABC, angle BAC is equal to 40 degrees, angle B is 75 degrees, and AD is the angle bisector of triangle ABC. Find the value of angle ADB. Because angle BAC equals 40 degrees and AD is the angle bisector of triangle ABC, then angle BAD would be half of angle BAC, which would be 20 degrees. And in triangle ABD, angle ADB is the same, so ADB would be this. This is the same as 180 degrees minus angle B minus angle BAD, which equals 180 degrees minus 75 degrees minus 20 degrees, which equals 85 degrees. So the value of angle ADB would be 85 degrees. You can see we use the triangle interior angle sum theorem. Here's a follow-up question. As shown in the figure, CD is the bisector of angle ACB. So ACB, which means that these two angles are the same. We know that DE is parallel to BC. Let's mark that out here. It's always helpful to write down your given information. Angle A is 50 degrees, 50, and angle B is 70 degrees, 70 degrees. Find the values of angle EDC, this angle, and BDC. Because angle A equals 50 degrees and angle B equals 70 degrees, therefore angle ACB would equal 60 degrees based off of the triangle interior angle sum theorem. And because CD is the bisector of angle ACB, then angle BCD would be half of angle ACB, which would be 30 degrees. So BCD would be 30 degrees, which means that ECD would also be 30 degrees. And because DE is parallel to BC, therefore angle EDC is the same as angle BCD. So this would also be 30 degrees. We're using the alternate interior angle theorem. So in triangle BDC, angle BDC is 80 degrees, and so this is our solution. Based off of the triangle interior angle sum theorem, we can conclude that angle 1 plus angle 2 equals angle 3 plus angle 4. So we can see when you look at these three diagrams, angle 1 plus angle 2 equals angle 3 plus angle 4. If you think about it, it makes sense. For example, if you look at this first diagram, there is a smaller triangle and a larger triangle, and the larger triangle contains a smaller triangle. So in triangle ADE, the interior angle sum would be angle A plus angle 1 plus angle 2, which equals 180 degrees. And in triangle ABC, the larger triangle, it's also equal to angle A plus angle 3 plus angle 4. We can later just not write this 180 degrees in the middle, so we're left with this equation, and then we can subtract angle A from both sides to get angle 1 plus angle 2 equals angle 3 plus angle 4. And if you try to apply this equation to the rest of these diagrams, you would also find that it's true. Because of the triangle interior angle sum theorem, angle A plus angle B equals angle C plus angle D. Here we have angle A plus angle B, which equals angle C plus angle D. If you think about it, it makes sense. We can see two triangles over here, triangle ABE and triangle CED. Angle AEB is congruent to angle CED because they are the vertical angles of each other. So that's why angle A plus angle B equals angle C plus angle D. Here's another example. In triangle ABC, apparently we don't have the picture, angle A is 3 times angle B. Angle C is 15 degrees greater than angle B. And find the values of angle A, angle B, and angle C. So we can let angle B be x, and let angle A be 3x. And angle C can be x plus 15. And when you add all three angles together, you should get a sum of 180 degrees. You simplify further to get 5x equals, what is 180 minus 15? That would be 165. And then x would equal 33 degrees. Therefore, the values of angle A, angle B, and angle C are each 99 degrees, 33 degrees, and 48 degrees respectively. Geometry problems are solved by using algebra and equations. You can see that here we had to write out and list out the equation and then further solve using what we learned about algebra. This gets turned into a more abstract problem when we turn it into equations. So you can see that in this problem, we didn't even need a picture. All we needed was equations and the substitution property of equality and the properties of equality. Here's some more practice. In triangle ABC, angle A equals 35 degrees, angle B equals 43 degrees. Therefore, angle C must equal 102 degrees. In triangle ABC, the ratio of angle A to angle B to angle C is 1 to 2 to 3. Therefore, triangle ABC is a right triangle when you find out the separate angle. In triangle ABC, angle A equals angle B plus 10 degrees. Angle C equals angle A plus 10 degrees. Therefore, angle A is 60, angle B is 50, and angle C is 70 degrees. Here's a final problem to expand your thinking. As shown in the figure, in triangle ABC, BP is the bisector of angle ABC. CP is the bisector of angle ACB. If angle BAC is 60 degrees, let's mark that out. So we already know that angle A equals 60 degrees, which means that the remaining angles, ABC and ACB, added together would equal 120 degrees. We know that BP bisects angle ABC, and I don't know why there's a 1/2 here. CP bisects angle ACB. Therefore, angle PBC plus PCB would equal 1/2, sorry, there should be a 1/2 over here, 1/2 ABC plus ACB, which equals 60 degrees. And we know that this equals 60 degrees because if we're going to multiply a 1/2 to the left side of the equation here, then we also have to multiply 1/2 to the right side of the equation. So half of 120 is 60. Because angle PBC plus angle PCB plus angle BPC equals 180 degrees, therefore angle BPC equals 120 degrees. So that's our answer. Follow-up question. Can you find the relationship between angle BPC and angle A? Solution. We know that BP bisects angle ABC, and CP, there's a 1/2 here again, bisects angle ACB. Therefore, angle PBC plus angle PCB equals 1/2 of the sum of angle ABC and angle ACB, which equals 60 degrees again. And because angle PBC plus angle PCB plus angle BPC equals 180 degrees, therefore angle BPC equals 180 degrees minus 1/2 of ABC and ACB. We know that over here. And when we rewrite that in terms of angle A, we get 90 degrees plus 1/2 of angle A, which means that angle BPC is 90 degrees more than the half of angle A. Summary. Today we learned about the triangle interior angle sum theorem. We learned that the sum of any triangle's interior angles is 180 degrees. We learned about the method of adding auxiliary lines and the purpose of these guidelines. So I hope you learned something from this video, and I hope you'll come back for the next lesson.